Apologies for the delay. I had to sort out a little technical issue there. Yeah, quick. All right, so let's just take roll very quickly and starting because we're a little behind time. Right, so I see an Aisha on the inside, Christian on the inside, D'Angelo here, Donovan there too, Julie on the way, right? So Hanifa here. Oh, hello, wife. Check WhatsApp. Oh, okay, cool. Yeah, no WhatsApp everything, right? So, right. So Jaden here, Javier here, Jaziri here, Jolie, Khalifa, Liam online, Logan online, Noah here, Naila here, Paige here, Zian here. All right. Okay, so we are continuing with the May 2024. Okay, this one. I just want to do part B now. Okay, what's that coming from? Right. Give me 1 second. Let me print this out for a couple of guys in class here. Right. Yeah, we did part A, so I'll just Yep. Did I give you 2 part C's by chance? Okay. Yes. Yeah. Well, there's 2 copies only. How well, she just said she couldn't make it, but I don't know what he said. Yeah, you got not too much rest. You wouldn't know.
So yeah, I just want to so I really like one. All I really did was change up some of the signs, but I still got the same answer, which is kind of weird.
Yeah, that's it.
Just wanted you to
Was it value? 1?
I got 1, yeah.
Oh no, yeah, well then that's why. Then you put 1 inside here, 1 minus 1 is 0. 0 squared is 0. 3 by 0 is 0. 0 by 0. So it'll just be 1.
Oh, so right.
Yeah.
Oh, really cool.
Yeah, no problems. Okay. All right, so ladies and gents, let's just take a quick recap of the part A to the question. All right, so we're on number 6 right now. We'll take a recap of part A, then jump into part B. Right, so ladies and gents on the far side, I start there. So in case you didn't know, right? So the talk had a kind of cut. Right, thank you. Okay, there we go. So in this question, take pi to be 22 over 7. So that might come into play if we have something with a circle or a cylinder to do. All right, so it says the diagram below shows a gold bar in the shape, oh, you got through? All right, of a trapezoidal prism, right? So a trapezoidal prism, right? So, or trapezium, right? A trapezium is this shape in the front here. It looks like a rectangle, somebody cut a piece off on that side there. So like if you extend that, you kind of get a rectangle. So they kind of sliced off a piece of the rectangle. And basically what they did is they took the shape and they kind of extended it into the 3rd dimension. So if you take a square and you kind of extend it back, you get what shape? You get a cube. That's also called a square prism. If you take a rectangle and you extend it back into the 3rd dimension, you get a cuboid, right? Also called a rectangular prism. If you take a triangle and you extend it backward into the 3rd dimension, you get a triangular prism. If you take a circle and extend it backward, you get a cylinder, right? Which you could also call a circular prism, all right? So basically, you could take any 2-dimensional shape and extend it and make it a 3-dimensional shape based on the front face, All right, that front face being the shape we should be accustomed with. So like, yeah, even if you take like a parallelogram, you could extend that back into the third dimension. So like some erasers have that kind of shape as well. All right, and the kind of red and blue ones. So any regular any two-dimensional shape can be basically kind of, think of it like a balloon, right? You have a balloon, it's flat. You can kind of see it's like a kind of teardrop shape, and when you blow it up, it expands into a sphere, right? So not exactly the best example, but you get what I'm saying. You could expand the two-dimensional shape into a third dimension, right? Now they then tell you here that the volume, right? So its volume is 2,886 centimeters. Sorry, the volume of any prism that's based on a two-dimensional shape is always the area by the height or depth into the third dimension, right? So it says calculate the area of the shaded cross-section of the trapezoidal prism. Now on the diagram, they give us two measurements. They give us the 31.2 and the 8.72, right? Now the 8.72 is this vertical here, which could be called the height, but that corresponds to this piece here. Was that a knock? Yeah. So quick question. Does the 31.2 centimeter, does that distance, does that length, is that found anywhere on the trapezium in the front face? No, it's not. Right? Yeah. Is the 8.72 found in the front face though? Yeah, it's this piece here. So so this item here is the depth, right, into the third dimension that we were talking about, right? So you'll take the area and multiply it by this value here, and that'll equal to the volume. So volume is equal to, as I say, area, then multiplied by height. Sorry. So what's the value of the volume? 2,886. We don't know what the area is, but that height, that distance in the third dimension is 31.2 centimeters. So if we wanted to solve for area, what would we do? How would we... Yeah, if you want to solve for A, you have to remove whatever's attached to A. In this case, what's attached to A? It's 31 point. It is. It is the height in the third dimension. Like I said, this is the vertical height, but this is the depth into the third dimension, which you call height. So you could call it height or you could call it depth, but it's the third dimension. All right? Right. So if you multiply by 31.2, in order to solve for A, we'd have to do the opposite, which is what? Divide by 31.2. So we'll divide both sides by 31.2. And let's see what we got there. So we have 92.5. So the area of that front face is 92.5 square centimeters. All right, so don't forget to put your units and put your proper units. All right, so that was that first piece there. Then they say that the cuboid shaped gold bar shown below, so this item here, has the same volume as the trapezoidal prism shaped gold bar displayed at A. Okay, so this has the same volume as above. What's the volume? Right. So has the same volume, which is the same 2886, right? Calculate the height. So in this case, the height is literally the vertical, right? Which we more normally associate with height. Right. Correct. So volume, like I correctly said, is length by breadth by height. So the volume is 2886. The length, well, we could say 8.2. It wouldn't matter because we're multiplying. The breadth is 30.6. And we don't know what the height is, right? So, but what do we have to do to solve for height, therefore? Right, which means we have to remove the stuff in front of it, right? Let me just write that back a bit neater. Right, by h. Right, so if we're multiplying both of those things by h, to solve for h, we'd have to then divide by them on both sides of the equation. So we have 8.2 multiplied by 30.6, and that's equal to h. Right, so let's plug it up in our calculator and see what happened in there. Right? That's on about right. Yeah, 11.5. So 11.5 centimeters. Right? So there's a standing instruction on the front of the paper that says any non-exact values can be rounded off to 3 significant figures and angles are to 1 decimal place unless the question specifies different. Hey, then Varuna, that's my brother name. All right, cool. Now, let's check out part B. So the trapezoidal gold bar is melted down and all the gold is used to make 6 identical spheres. Now, when you melt the bar down, does it change the total volume involved? No, it doesn't. So basically what they did is it took that 2886 of volume. So the volume given to us on the previous page was 2,886 cubic centimeters. You melted that down and used that to find the volume of all, and use that to make 6 identical spheres. Calculate for each sphere of gold its radius. So here, in all of these things, art maths now is regular maths. This is CSEC maths. This is the May 2024 paper from last year. Yeah. Okay, so check it. And they give you the volume of a sphere on the paper itself, right? Okay. So check it. You melt down this thing and you form 6 identical spheres, right? So all 6 spheres put together, the total volume would be 2886. How would you then find the volume of each individual sphere? Correct. So if we start off by taking the volume, right, and then divide by 6, we would find the volume of each sphere. So 2886 divided by 6. That's 481. That's correct. So 481 cubic centimeters. So this is the volume of each sphere. Of one sphere. What they want us to find is the radius. Now this is the formula for the volume here. Right? So we know what the volume is. The volume is 481 cubic centimeters. And that's equal to 4/3 multiplied by pi. So pi is 22 over 7. And r cubed, right, is the last part of the formula there. Right, so to solve for r cubed, the first thing we have to do is move this to the next side. How are those things attached on this side? What operation? And to remove things attached by multiplication, we have to use the opposite operation, which is division. So we divide by, now you can put them back as is, 4/3 by 22 over 7. And that's equal to r cubed, right? Therefore, r cubed is equal to, so let's take a look and see what happens there. So we have 4 over 3 multiplied by 22 over 7. Yeah. If you could, cool. If you want to dig out, no problem. All right, cool. Sounds good. All right, cool. Right, so we have about that, and then what we'll do is we'll invert that and multiply by 481. So we get about 114.78. Let me just double check that calculation, right? So 4 by 22 is 88, and we're dividing that by 21. Right. So then it's 481 divided by that. So multiply that by 481. Yeah, so 114.78 blah, 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 right? So r cubed is 114.78 dot, dot, dot. Now, if that's r cubed, how do we find r? How do we undo a cube? We have to find the cube root. Yeah, approximately, yeah. Right, so you find the cube root of that. We have about 4.86. centimeters, and this of course is correct to 3 significant figures. Oh, who's the one girl inside? Sarah? Haley? Christine? I'll come and see just now. All right, cool. Right. So let me just recap that. So they told us initially in the question, the trapezoidal gold bar is melted down and all the gold is used to make 6 identical spheres, right? Calculate for each sphere of gold its radius, and then we have a next part of the question, right? Now, when they melt down the bar had a volume of 2,886 cubic centimeters. That's the volume of the initial bar that they then melted down. Conflicts, GD. Hey, how are you doing conflicts? Right. Right. So if they use this to make 6 spheres, to find the volume of each individual sphere, we will take the 2886, the total volume, and divide by the number of spheres. Right? In doing so, we got exactly 481. And then they want us to find the radius of each of those spheres. Each of these spheres has a volume of 481 cubic centimeters. Right. So we take the formula, we substitute the value inside of it. So 481, right? That's equal to 4/3. So the 4/3 is given to us. The 22/7 as pi. That was in the previous page. Remember they told us at the top here? Take pi as 22/7. Right? So use the values that they give you, right? So this here, right, is multiplied by r cubed as per the formula, right? The formula is right there. It's given to us. To solve for r cubed, the first thing we'd have to do is remove the item I've boxed off there, right? Those two things are connected to r cubed by multiplication. To remove anything attached by multiplication, we use the opposite operation, which is division. So we divide by that. Now, again, you could put it as that, or if you wanted to, let me just do a different color, right? If you said, okay, 4 by 22 is 88, 3 by 7 is 21. So if you said, okay, you did 481, then divided by 88/21, that's equal to r cubed. And then with what was the protocol? Yeah, what's the protocol with division of fractions? You change divide to multiply and you invert the divisor, right? Right, so even if you did it that way, you should still get the same value. Let's double check. So 481 by 21, then divided by 88. So 114.78, right? Which is the same thing we got here, 114.78. Now that's r cubed. R is to the power of 3. So to undo a cube, you have to find the cube root. Not so, Jolie? Yes? What are you saying yes to? That if you have, well, I realize that's why I asked you, right? So if r cubed is equal to 114.78, but you want to find the value of r, you have to undo the cube. So if, let's say x squared was equal to 9, to solve for x, you have to find the square root of 9, not so? So to undo a cube, you have to find the cube root, right? So of course, you're going to find the cube root on both sides. The cube root of r cubed is just r, and the cube root here, you plug it into your calculator, and we get approximately 4.86. All right? You're so lost. Well, I don't know how long you're following, so if you just jump in, then yeah, you might be lost. But let's continue and see if you get unlost. Right. And then the last thing they want is the surface area, and they gave you the formula. So the formula for the surface area is 4 by pi r squared. So if you didn't work out the surface area, I'll give you a minute or two to find that. So this, of course, here, that's your r. Right? So they want the surface area of the sphere, which is 4 by pi by r squared. So write it out. So put a is equal to 4 by 22/7 by 4.86 squared. And then you could plug it up in your calculator and see what you get. Right, look at it, 4 pi r cubed, pi r squared, sorry, right? So 4 is a constant, pi is the 22/7, and r is the 4.86, but you had to put square. Yeah?
4 multiplied by 22.
Yeah. Mm-hmm. That's correct, yeah. They want the surface area. Formula is here. Not. This is one of the very. Yeah, that's why you had to find the radius. Yeah. Yeah. Not. They don't usually do this, to be honest. Most times the formula in the front. Okay. Right. So like I was saying, they want the surface area. Ah,
So this is one mark. If I now put the centimeter squared or meter squared, right? It's not so
you can't lose the whole mark.
large.
You can't. I think that would be very I think that'd be very harsh. They might overall see, okay, was this person, I mean, I have to find out, to be honest. Right? So 4 pi r squared. So it's 4 over 1 pi. So again, remember pi, this is just an estimate. Pi, we don't have an exact value for pi. 22 over 7 is an estimate of pi. Right? It's actually Archimedes' upper bound. Right? It's the max value. It couldn't even reach the 20 over 7 by r squared. So that's 4.86 squared. Right? So again, this is calculator food, as I like to call it. So you plug it in your calculator or calculate earlier. Right? 4 by 22 by 4.86 squared. And divide by 7. So 296.9. So 297, anybody?
I just keep the last 2 lines.
Sorry, what?
I kept the last 2 lines.
All right. Okay, cool. Am I live on YouTube? I am on YouTube and TikTok simultaneously. The YouTube is recording for class, and the TikTok is my backup recording, because sometimes the YouTube occasionally doesn't record properly or something. Right. Okay. Google Meet. I didn't forget earlier. I just was trying to sort out some stuff. Right. So Aisha, Christian, Donovan, Liam, and Logan. If you guys are good with this page, let's give me a G in the chat. If you need me to go over, give me a R. Right. And it's not a problem. Right. I understand. I went through a lot. So if at any point in time you got lost, you have to let me know. Right. Because the point of it is you need to understand what we're doing. Right. Yo. Yeah? Yeah, that was the radius from the previous part of the question. No. Remember, we got it on top of here. Right? That's the radius of the axis to find. Right. Okay. Right. Let's get some water, and then we'll bounce back in. Okay. Right. So I'm gonna send pics in the chat as we go along. Maths. Right. So let's just stop that. Right, yeah. So it's a little zoomed out, so you might want to zoom in for each particular part. All right, okay, cool. Okay, so ladies and gents, let's check out 6 part C. They want the mass to the nearest kilogram, given that the density of gold is 19.3 grams per cubic centimeter. So they want the what? They want the mass. All right. Now look at where the mass is in the formula. Mass is density over volume. But they've given us density on top of here, not so? So we have density, and from the previous question, we have the volume of each sphere, of each one, right? So we have, oh, come the man, Philip, give yourself, right? Yeah, it was 481, right? Right, so you could plug in your values first. So you're hiring, or, actually, yes, I am. If you want to discuss that further, send me a DM. You could email me. As a matter of fact, that might be the better route to go. And let me know we could discuss. Yeah, so we could discuss and see what you have in mind, and we can figure it out. Yeah. Okay. Right, so your density is 19.3. We don't know what the mass is, so leave it as M, and the volume was 481, right? So that's what you should have. So I'll give you a minute to rearrange and recalculate, see what you get. Oh, this was the extra. Uh-huh. Yeah. Right. So the answer to that, which is a very good question, right? So if you didn't get a previous part, how do you work with the rest? If it is, let's say, for example, they made a mistake in the part where they asked for the volume, right, or the radius, right? What they would do is watch your process. If you have clearly laid out your steps, and they can see that, hey, you're doing the right thing but with the wrong figure, you will get piece of the mark, because one piece of the mark is for process and piece is for solution, right? So if they know that, hey, we layer this thing so that the answer from part 1 goes into part 2 into part 3. If that's the case, and I say, okay, look, if they get the answer in part 1 wrong, what's the process in part 2 and get marks for process, right? And then they call it error carried forward. Just like in POA. In POA, let's say you make a mistake with sales minus cost of sales and you get the wrong gross profit, right? But if everything else is correct, you will still get the mark for the figure you have as the net profit. If they give that, they call it again error carried forward, or it was also called the own figure rule. All right, so if we want to solve for m, which is the numerator in the fraction, what is the understood operation between numerator and denominator? Divide. So if you want to solve for the numerator, you have to remove the denominator, which means you're going to have to use what operation? Multiplication, the opposite of division, right? And of course, whatever happens on one side of an equation must also happen on the next side. Very good. You see, you hear it often enough, it sticks. Like I tell you, I want to be that voice in your head when you go in the exam and you're thinking through things. You hear my voice, right? Yeah. So 19.3 by 481. Right, so that's actually a very good thing. Thanks for pointing that out, right? So we get here, what, 9283? Right, that's equal to the mass. But, as...
Yeah, 92.93.
Oh, 0.3, sorry, yeah. Sorry, thank you very much, yeah. Right. But as Javier correctly said, this is actually in grams, because look at, what's the unit here? Grams. And then we would have put the volume in cubic centimeters, right? So we will get grams. But what they want the answer in? How many grams in a kilogram? 1,000. So to go from grams to kilograms, you have to divide by 1,000, which means shifting the point 1, 2, 3 spaces to the left. So, oops, careful. Yeah, careful with that. I want to buy a new phone, but you see, that's my biggest fear. If I spend 7, 8, 10,000 on a phone and drop, what is my position? You understand? Right. So here, if we take the 83.3 grams and divide by 1,000, right, we get 9.2833 kilograms. But they wanted, what they wanted to? The nearest kilogram. So it means that they want no decimal places, right? But we have to see if we have to round off. What is that digit? That's a 2. So it's not 5 or higher. So if it's not 5 or higher, we don't round up. So if it was 5 or higher, we would round 9 up to 10. Correct, it would have been 10. So what would happen here is that we would just get 9 kilograms. Well, that would have been 9 point, so 1 decimal place, but they set it the nearest kilogram, which means they want no decimal places. All right? It's like rounding up somebody's age. So let's say my son is 2 years and 4 months. He's 2 years old. You know? Yeah. I hear the crazy part. He was at one point, when he was younger, he was already 35 pounds. And he gets sick for like 5-6 weeks, and he lost weight, so he's on to 31. My second son will be 4 months on Monday. He's already 17 pounds. So he's already half the weight of his brother, who is 2 years older than he is. Yep. Yeah. But my wife not telling me they're holding on, and well, because he hasn't been eating properly recently. You know, only yesterday he had a piece of my calzone. Hey, I was telling you I ordered calzone yesterday, girl. Yeah. Start with question quick. Look, your stuff across there. I think you have more room there. It'll be too crowded here, so just have a seat there. I think Peter will can help you out, so you can just sit down. There's space right there. Paige, you'll help out Jake when you get a chance, right? All right, cool. All right. I'll give you a copy. You had A, B, and C there for part 6? No. This is same part 6. Just see if you have part A, B, and C. I'm now gonna print out part 7. You have A, B, and C?
No, I see.
You have C? All right. Right, so we just finished that part then. So we're going on to part 7. Question 7. All right, so Google Meet. right? So I'm gonna call out your government name. So Aisha, Christian, Donovan, Liam, and Logan. If you guys are good with this stuff on the screen, the item in the blue, just give me a quick G in the chat. If you need me to re-explain, let me know. Please answer. Oh, okay, cool. All right, where? Aha, I know what to ask a question. Okay, right. All right. Okay, so folks, we're going to question 7, but I have to print out that piece for sorry, it's 3 guys, right? So Jaden, Javier, and Jaquan. You have a whole paper already, right? Ladies, you all have your full paper, everything? All right, cool. All right, so just give them a couple of minutes to sort it out. Hey, be yourself. Right, so we're doing. Actually, we're not even bound for. I'll give you the whole question because you can practice it because it's still marks. Right? I don't usually do the actual drawing because I think it's simple enough for you all to do, but we will take a look at it, right? This is the next part here that is actually the. Yeah, to draw it freehand. Yeah, and ruler boy to draw that kind of diagram. I think that was a poor choice of shape on their side, but again, who knows? Yeah. Once you have room, you could draw it, and you even have spare paper at the back. You're supposed to, right? All right. Okay. So just give me a second. Then Google Meet. I'm gonna just give all these things here. All right, ladies and gents, let's take a look at the questions. You'll get a minute. Well, you'll get some time to try the question. Okay. So the diagram below shows the first 4 diagrams in a sequence of regular hexagons. Right. The significance of the word regular here means that all of the side lengths are equal. So you know how like in a triangle, if you have an equilateral triangle, all the sides are of the same length? And in a square, right? A square has all equal sides, right? So once you see the word regular in front of that shape name, it means all of the lengths are equal. And a hexagon, how many sides does a hexagon have? 6 sides. Each regular hexagon is made using sticks of unit length. When they say unit length, it just means it's a measure of one whatever unit. So if it was centimeters, it was 1 centimeter. If it was inches, it'd be 1 inch, that kind of thing, right? So that's what the word unit means, right? Of length 1. Now, in this diagram here, you have 1 on top and you have 2 below, right? In the second diagram, you have 2 on top and then 3 below. In the third diagram, you have 3 on top and then 4 below. And in diagram 4, you have 4 on top and then 5 below. So in this particular diagram, in this pattern, what's happening is that you're increasing by 2 hexagons every time, but 1 in the top row and 1 in the bottom row. Agreed? So in diagram 5, you'd have 5 hexagons on top and 6 below. So yeah, if you take a couple seconds, see if you could draw it in there. I'm not necessarily a fan. I don't know why they give it in this particular format, but anyhow, I will try as well. Not a fan. 1, 2, 3, 4, 5. So I just need 1 more on this side. All right. So 1, 2, 3, 4. Oh, I'm gonna put 1 on this side too. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right. Okay. Yeah. I think you're good there. All right. I'm gonna stick up. Right. So this thing is already pressure. A short straight line. All right. So let's take a look at part B. And so this is where the money is, right? So I like these questions because over the years I've come upon the understanding that maths is the study of patterns, right? And this question is a patterns question. I mean, the other questions have their own kind of pattern, but this one is kind of direct. Now let's take a read. The number of regular hexagons, H, the number of sticks, S, and the perimeter of each figure, P, follow a pattern. So you have hexagons, sticks, and perimeter. All right. So the values for each of these for the first 4 diagrams are shown in the table below. Study the pattern of numbers in each row of the table and answer the questions that follow. Right. So the trick here is you need to look at the change as you go down in each column. For example, to go from 3 to 5, that's a change of what? An increase of 2. 5 to 7, as an increase of 2. 7 to 9, an increase of 2. So if you go to the next one, so 1, 2, 3, 4, 5. So in row 5, we have to add 2. 9 plus 2 is 11. Good. What about number of sticks? So 15 to 23, that's an increase of 8. 23 to 31, that's also 8. 31 to 39 is also 8. And again, it's from 4 to 5 now. So all we'd have to do to find the item here would be to add 8. And 39 plus 8 is 47. Now for perimeter, they didn't give us one to fill in, but let's analyze the pattern nonetheless. 12 to 16 is an increase of 4. 16 to 20 is an increase of 4 as well. So it's a constant increase. Now, whenever you have a constantly increasing item, any add math people here? No? Okay, cool. Right. But basically what you have here is what we call a linear function. You all know coordinate geometry and straight line, equation of straight line? Right. So each of these, if you work out the pattern, could be written in the form like y equal to mx plus c. Right? Where m is the gradient. But guess what? We know the gradient already. What is the gradient? The gradient is the change from one to the next. In the pink section, what is the change from one to the next? 2. In the green section, it was, and in the blue, it was 4. Right? Now, they want us to fill in a few other things. Let me get some different colors, right? So they want us to fill in the orange and the purple. Now, my advice is to fill in the purple first because the purple will give you the kind of formula, even in pre-tab, how you doing? Yeah, the purple will give you the kind of formula that you could then use to go back and use to solve for the orange, right? And to find those formulae for each of those, I'll show you. It's once you see it, it's like seeing a magic trick. Once you see how to do it, it's kind of spoiling magic. But you know how to do it, so now you can impress other people, right? Okay, so what you're going to do is you are going to, like, I'll use the first one, the pink one as the example, right? You're going to take this gradient, this change, right? And you're going to multiply by this item, right? What is 2 multiplied by 1? 2. And how much do I have to add to 2 to get to 3? 1. Okay. Now, again, this is 2 here. I'm going to take the same 2, which is the change, and multiply by the diagram number. So 2 multiplied by 2 is 4. And how much do I have to add to 4 to get to 5? 1. Was it the same pattern as above? The same kind of, right? What about in 3? If I took the same 2 and multiply by this diagram number 3, what's 2 by 3? And how much do I have to add to 6 to get to 7? Ah, let's try it one more time. If I take 2 and multiply by the 4, 2 by 4 is? And how much I have to add to 8 to get to this 9 here? 1. So what's the pattern here? 2, wait, you could use N or you could use D, right? And just to cross check it, 2 by 5 will give us what? And 10 plus 1 is 11. So 2 by 5 is 10, then plus 1 is 11. So for this one down here, all right, yeah, so sorry, you could use N, my bad. They did say N. Sorry, Noah, you had a question? Uh-huh. Let me see. It might be, yeah. All right, so Noah is saying if we take the 8 and multiply by the 1, right, we get 8, correct. And to get to 15 from it, you have to add 7. I agree with that. Let's see if it holds. If we take 8 and multiply by 2, right? 1 second, sorry. So if we take 8 and multiply by, how much we get? And if we add 7 to 16, do we get 23? Yeah, we do, right? Now you can check out the rest if you want. Let's check out one more. If we take this 8 and multiply by the number 3, diagonal, 8 by 3 is what? 24. And if you add 7, you do get 31, right? So the pattern here is what? 8n plus 7. Right? So 8n plus 7. All right, so I want you all to try the blue one. All right, so don't call it out yet, right? We'll get there just now. Yeah, there's one for all of them. Okay, so something up with that. Oh, hey Ray, thanks very much for the follow. Oh, hey Gabe, thanks very much. I see it. I guess yeah, you fed up on maths. I have to sneeze. Sorry, my bad. Yeah. All right. What by? All right. Cool. Thank you, Pritavi. Right. So, anybody? Anything? So if we take 4 and multiply it by 1, we get 4, right? How much you have to add to that to get 12? Gotta add 8. Okay, cool. All right, what about this one? 4 by 2 is 8, and 8 plus 8 is 16. And let's check it one more time. 4 by 3 is 12, and 12 plus 8 is 20. So I think we have 4n plus 8. Well, there are different ways to go about working it out. There's just the way I choose because I find it's simple enough to kind of explain to most people. Oh, you mean checking as I go along? Right. So one of the other ways you could do is using, well, it's more in the realm of add math, but it's not that hard. It's something called arithmetic progressions. Basically, it's a pattern where you start with a number and you keep adding the same. Well, it don't have to be that number. Let's say you start with 3 and you keep adding to it. 3 plus 2 is 5 plus 2 is 7 plus 9, right? So the first term we would let it be notated as A. That's the first term, right? So let's take the blue, right? So let's say the first term is 12. And then what you want to find is something called the common difference, which is how much you have to add the same number that you keep adding over and over. In this case, that's 4, right? Right. The formula for the term, what they call term n, right, is equal to A plus n minus 1 by d, right? So A is 12. Now we don't know, well, n is just what number it is, and d is 4. So what we do is we'd expand using distributive law. 4 by n will give us 4n. 4 by minus 1 is minus 4, right? So now when you rearrange, you could have 4n plus 12 minus 4. And what's 12 minus 4? 8. Right? So you could do that too. Yeah, no problems. Right, so n to the power 4 to find. But yeah, Pritavi, that was what Jada was not asking. All right, okay. Google Meet. Before we do the orange dots, can I just get a G if you guys are good with how I found the 3 formula below? If you need me to re-explain, let me know. Or like the simpler way. Yeah, it has different ways to do it, you know? And some ways are more palatable than others to some people, which is perfectly fine. All right, so Liam, Aisha, Donovan. All right, Christian. R. Okay. Okay, Christian. Is there a specific one you want me to go over, like the the pink, the green, or the blue, or is like, or are you talking about the thing on the side here? The blue. All right, cool. Yeah, and thanks for being specific. I appreciate it. Right. Okay. So let's just go over the blue one more time. Right. Right. So again, the first thing to analyze here, if you're doing it this way, is to analyze the increase at each step, right? So to go from 12 to 16, that's an increase of 4. Same thing, from 16 to 20, that's also an increase of 4. From 20 to 24, that's an increase of 4. So we see the same value appearing over and over. What we do is we use this value in conjunction with the diagram number, right? And we multiply them. So we multiply 4, which is the increase, by 1. That's 4. And we ask, how much do I have to add to 4 to get to 12? And the answer is 8. Now we double check. If I take 4 and multiply by diagram number 2, right, as in 4 by 2, I get 8. How much do I have to add to 8 to get 16? And the answer there is I also have to add 8 as well. So we see the same pattern kind of emerging. So if we check it 1 or 2 more times, we should be fine. So if we take the 4 and multiply by the diagram 3 number, which is, of course, just 3, we get 12. And to get to 20 from 12, we have to add 8. So we kind of confirm it there, right? So we take this increased value, the 4, multiply by the diagram number, which they just put in as n for now. And then after that, you just analyze how much you need to get from whatever that product is to the value they give you in the middle column here. Right? So I hope that helps. On the purple. Okay, the purple, right, Christian? That's what you're asking about? This stuff here? Yeah, I'll do that part again. Right. Okay. Yeah. So the question was, is there like a formula you could use to find these expressions or relationships down here? And the answer is yes. Right. Okay. Do I have a different? Okay. I'll use this kind of darker purple. Right. Okay. So the formula you could use is something from AdMaths called an arithmetic progression, or AP formula, for what we call the nth term. And it's a plus n minus 1 by d, right? I need to explain what a is, right? So a is the first term, right? D is the common difference, right? Which is the amount you have to add every time to go from one number to the next, right? So, sorry. Hold on, wait. 1 second. Just wanted to check something. Right, okay. That's fine. Sorry, all of a sudden I just felt like nobody was hearing me. Right, sorry. How did you get the formula for Tn? Desha, that's a formula from AdMaths. It's like so I'm going to do it again. So it's a formula I know that I just kind of sharing. It's not hard to derive, but we'll have to do a whole separate session on that, which I'm not prepped for right now. So I do apologize. But yeah, but that's a formula. Sorry. All right, cool. All right, so in the case of the perimeter, the first term was 12, right? So A was 12, and the D was the 4, right? The N, right, that's any number term. So we leave that as an unknown, right? That's a variable, right? So to find the nth term, we're going to take 12 and add n minus 1, then by 4. Right, so from here, we expand here using distributive law because multiplication is understood between the bracket and the 4, right? So 4 by n will give us 4n. 4 by minus 1 is minus 4. So what we do is we just kind of swap places, right? So we put the 4n in the front and the 12 next to the minus 4. And 12 minus 4 will give us 8. And that gives us the same formula as we got down here in the kind of brighter purple. Sorry, 1 sec. Yeah, okay. All right, so Christian, I hope that helps a little bit. All right, you can let me know when you're ready. All right, and what was it? It was Desha. Yeah, Desha. So I hope that helps as well. All right. Okay, now that we have those two formulae, what if you have not yet done so? I want you to find this item here in the orange, and this item here. What's that? All right, no worries. Mr. Take Your Money. That's a fun name. Is it Nick or Nikki? Shanti. Yeah, okay, I thought it was an L. My eyes not as sharp as they used to be. Yeah, one of the hazards of staying alive and getting older. And not taking care of yourself properly. Right? So what you could do is you could use this formula here, put it equal to 47, and then solve for n. And you could cross-check that by putting this formula equal to 191, and then solving for n. And then after you solve for n, you have to plug it inside of here to find the value above. Yeah. Right. Yeah, that's it. Yeah. That's the n. And that's where you have to plug into 4n plus 8. No? Alright, let me take a look and see what's going on, right? Alright. Okay. Right, so if 2n plus 1 is equal to 4, sorry, I put that too high. Right, so 2n plus 1 is 47. So the first thing to do is to minus 1 from both sides, right? So 2n would be equal to 46. Sorry, minus 1. And then to solve for n, I'd have to divide by 2. So n would be 23. Now to cross-check that, we could check it here too, right? We could put, sorry, one sec. We could put 8n plus 7 equal to 191. So first things, to solve for n, you subtract 7 from both sides. So you get 8n is equal to, I think, 184. And then you divide by 8. And 184 divided by 8 is 23. Yeah, so you get the same value. And now to solve for the orange one on that side, you just plug in n is 23 there. So you get 4 by 23, which is 92. Yeah, and 92 plus 8 is equal to 100. Okay. All right, cool. All right. And there's a last part here. Skylar says that she can make one of these figures with a perimeter of exactly 1005. Explain why she is incorrect. So which was the formula for the perimeter? The purple, well, sorry, this one across here? Right, so she's saying that she can make one with the perimeter is 1005. Now, there's the formula for the perimeter. So the question is, if you put this equal to 1005, what's the value of n? All right, so do that. Skylar is saying that she can make one of these figures with a perimeter of exactly 1005. Right? This last column here was the perimeter column. Huh? Yeah, and the formula for the perimeter is 4n plus 8. So the question is asking, why is Skylar incorrect? Why is it incorrect? In other words, if she is incorrect, it means she cannot make a formula, sorry, she cannot make a figure with a perimeter of 1005. And I can tell you why, like, first of all, I could do a little number theory on here, right? What kind of number is 1005? Odd or even? Odd number. The only way to get an odd number if you add two numbers is if you have one odd and one even. Because if you have two evens, you get even. Take any two, let's say 4 and 6, that's 10. 4 and 8 is 12. 2 and 6 is 8. So any two even numbers give us back an even number. No matter how many even numbers you add together, you'll always get an even number. Two odd numbers also give you an even number. What's 1 plus 1? 2. 3 plus 3, 6. 5 plus 3, 8. 9 and 7, 16. So if you have the same, I'm not sure what to call that, but same types, two odd, two even, you'll always get back an even. So, huh? Well, right. So if you multiply as well by an even number, 4 is an even number, right? 4 by n. 4 by any number will always give us back an even number, right? Right. Think of your 4 times tables. 4 by 1 is 4, by 2 is 8, by 3 is 12. It's always going to, because remember, what is your multiplication table? Repeatedly add in 4, right? So if you have an even number and you keep adding 4, which is an even number, you're always going to get even numbers. So any multiple of an even number is itself an even number. So this is even and this is even, and the sum of two even numbers could never be odd, right? Now that's the number theory side of it. But what they want you all to do is simply to say, look, she is saying that the perimeter is equal to 1005. This formula gives us the perimeter. So if we put that 4n plus 8 equal to 1005 and solve for n, let's see what we get. So the first thing, to solve for n, we have to remove the 8. How is the 8 attached? What operation? Addition. So to remove it, we have to use subtraction. So we're going to subtract 8 from both sides. If we subtract 8 from this side, it'll cancel this 8, leaving us with 4n. If you subtract 8 from this side, then you get 997. And now to solve for n, you have to remove the 4. How is the 4 attached to the n? And to remove something attached by multiplication, we use division. So if you divide by 4 on this side, it'll cancel with 4, giving us n. But then we get 997 over 4. 997 is what kind of number? Odd or even? Odd. If you divide an odd by even, you will not get a whole number. Right? So 997. So, what will we get, boy? That is 2. That will give us 49.25. Right. And they might say, well, look, that's the value there. But remember, what are we solving for? The figure number n. And n could only be, like, I think we call it an ordinal number. It could only be an integer. Right? It's like first place, second place, third place, fourth place. You can have a 249 and a quarters place. That happening. Right? Okay, right. So to solve for part C, she says that she can make one of these figures with a perimeter of exactly 1005. And you say, put that equal to 1005 because that's the formula for the perimeter. And this is what we get. So therefore, she is wrong. If you explain it properly, you should be able to get it. There's only one mark, you know? They could say 4 by n is even, 8 is even, the sum of two even numbers is even. Therefore, Julie is incorrect. Sorry, but Skylar. I did, I don't know why. Belsky, how are you doing? Alright, Google Meet. Right, Aisha, Christian, Donovan, Liam, and Logan. If you guys are good with part C as to why Skylar is incorrect, just kindly give me a G in the chat. Please understand. Oh. Hey Julie, how you doing? Good to have you on. I was now updating my rule and I'm not reaching him. I'm like, oh, Julie, I'm like, yeah. So you have real impeccable timing. I think Mishka's supposed to be here tomorrow for Almat, so she wanted to pop in. Just confirm with her. But yeah, she's supposed to be here. Because she said you wanted something explained with the integration or something. So, anyhow. Alright, cool. Alright, yeah, okay, so we finished off question 6, we just finished question 7, so now we're going to question 8. Alright, okay, so Liam, Donovan, Aisha, who is it? Liam, Donovan, so, oh, Christian gone, okay, well, I guess he might pop back in. Alright, so Logan, you'll let me know. Okay, right, so let me just scroll on a little bit here. Ooh, question 8 has a few pieces, boy, can I finish question 8? Let me see. All right. Yeah, okay, I'll go back this one. Give me one sec. I'll put this to print for the gentlemen who don't have papers. Papers. Come on, man. Philip, give yourself. Yeah. Oh, wow. Okay, no, so you can come down 2 lines. All right, I'll zoom back in just a. Let me just print out this stuff for the guys in class who don't have it. Oh, needs paper. All right, there you go. All right, I'm gonna zoom in here. Right, so those who know how to do functions, go ahead. Those who don't, just hold on a second. Right, so with functions is some basic substitution. So for g of 2, you're gonna sub 2 into the function g, where we have x. F inverse of 3, put 2x minus 1 over 3 equal to 3 and solve for x. That's not it. Alright, ladies and gentlemen, screen there. Right, so I'll give you a minute or two to finish that piece, that page there. Then we will proceed. Right, okay, cool. Oh, YouTube, alright. Yo. Right, if they wanted an expression for f inverse, yes, but there's an easy way to do it. So what you could do, just put whatever f of x is, the 2x minus 1 over 3, put that equal to 3, and then solve for x. Because what they're asking here, the f inverse of 3 means that the value of f is 3. What they're asking for is what x value makes f equal to 3. Equal to 3, and then solve for x, yeah. What was the reason? What was the reason? Oh, this piece here? Which one is that page?
Oh no, I'm just showing questions.
Which one? Question 8?
Yeah.
Which part? The
The
inverse?
F1 3. I'm just because I did the G2,
Right.
which was
Yeah. Well, the easy way to do it is, okay, so f, the function is 2x minus 1 over 3.
Yeah.
Right. Put that equal to 3. And then solve for x. It's the easier way to do it.
Sure.
Yep. When you want to find f inverse of a value, right, what they're asking is what value of x would actually give you that 3 when you plug it into f. Alright? I could go back to 8 now? Yeah. I'm gonna see one of these, boy. Wow. Pretty cool.
Can I do this for this one? If they said F
FG.
Is it
Right.
everything of G into X? Into F.
G into f. So it's G
I
into
did
f,
it.
yeah. So I think you did GF.
I put G as one.
Yeah, yeah.
This one battery reaction.
No, okay, hold on. Yeah. Alright, cool. Sorry. Alright, there we go. Aha.
So what after that just multiply just 2 by everything.
Yeah.
So the 2 by the 10 minus 2x squared minus 1.
Yeah. Yeah. Alright. Let's take a swing here, ladies and gents. Right, so to find g of 2, you're going to sub 2 inside of here. Alright, that's equal to 5 minus 2 squared. What's 2 squared? 2 by 2 is 4, and 5 minus 4 is 1. There you go. Alright, I'm going to... Right, now, for the f inverse, so most people will find an expression for f inverse and then sub 3 inside. You can do that. But if you want to save us a little bit of work, what you can do is simply put this equal to this value and then solve for x. What an inverse does is it's asking for the reverse. What does that mean? Addition and subtraction are inverses, right? Subtraction undoes addition. Multiplication and division are also inverses. They each undo each other, right? Now, an inverse doesn't just apply to an arithmetic operation. It can apply to a whole process. When you're transposing to make something the subject, you're technically inverting with respect to that. So when you want to find f inverse of 3, instead of subbing 3 into f, right? What they are asking you to do is they're asking you, what value could I sub in here to get 3 as the output? So normally the value in the bracket is the input to get an output. If you're doing an inverse, what this is the output, and they want to know what the input was. They want to know what value, when I find f of that value, gives me 3. So what I'm going to do is you're going to let the function 2x minus 1 over 3 equal to 3. Right? So let's do this in traditional transposition, right? So to solve for... Sorry. Yeah, sorry, what? I thought you were talking to me. Yeah. To solve for x, we'd have to, first of all, get rid of that denominator. How do we get rid of a denominator? Right, because we divide by denominator, and to remove something attached by division, we have to use the opposite operation, which is multiplication. So if you multiply by 3 on one side, it'll cancel that, leaving us with just the numerator of 2x minus 1. And of course, whatever happens on one side of an equation must happen on the next side. So 3 by 3 on the right-hand side will give us 9. Next, let's move the minus 1. So we're subtracting 1. So one way you could do it is this, right? You could ask, okay, if I'm subtracting 1, I have to do the opposite. What's the opposite of subtracting 1? Adding 1. So if I add 1 to this side, it'll cancel the minus 1, leaving me with 2x. And then 9, of course, whatever happens on one side has to happen on the next side. And 9 plus 1 will give me 10. The last thing to move is the 2. How is the 2 attached to the x? Multiply, and to remove it, I have to use division. So x would be equal to 10 divided by 2. Therefore, x would be equal to 5. Now, check this, right? I want to do this in a slightly different way, just to kind of to really think through it. Here, with the function, I have 2x minus 1 divided by 3, right? So if I start with my x, the first thing done to the x is I multiplied it by 2. Then I subtracted 1, and then I divided by 3. So, check this. If I put that equal to 3, right? So this is telling me that some number divided by 3 is equal to 3. If you know your 3 times tables, we know that the only number we could divide by 3 and get 3 is? The only number we could divide by 3 to get 3 as the answer is? 3 divided by 3 is 1. But something divided by 3 is equal to 3, and that's 9. So this number, this numerator, has to be 9. Next, I'm saying that some number minus 1 is 9. What's the only number I could subtract 1 from again? Hey, I see what's going on. Yeah. What's the only number I could subtract 1 from again? 9. 10. So 2x has to be equal to 10. And this is saying 2 multiplied by something is equal to 10. What's the only number I can multiply by 2? Correct. That's equal to 5. Right? And I'll show you one more way. Oh, like the actual expression? Yeah, no problem. Right, so check this. This will kind of lead into that, right? If you look at the x, the first thing done to the x, right, is so the first thing done was I multiplied by 2. The second thing done was I then subtracted 1. And the third thing done was then I divided by 3. To invert the function, you literally have to go in the opposite direction of all of those things. You have to undo all of those things starting from the last thing done to it, right? So this was f, right? F of x. If I'm inverting, right? If I want to find f inverse of x, I have to start from the bottom and go up. So the first thing I would do if I'm inverting is I start from here. How do I undo divide by 3? How do I undo division by 3? Multiply. How do I then undo subtraction of 1? Either add back 1. How do I then undo multiplication by 2? I do divide by 2. So to do f inverse of x, therefore, what I would do is I take x. The first thing would be multiply by 3, then add 1, and then divide by 2. Right? So again, it's one method. The other method is the more conventional transposition. Right? So that what you would do is you'd put y here, let the function equal to y, and then 1 by 1, make x the subject, and then just switch out x and y. All right. Yeah, I see you on the ball there, boy. Okay. Before I go on to the next page, I just need to ask if you're all okay. So Google Meet, right? Those of you who are left. Oh, I think Christian came back. Okay, good. So Aisha, Christian, Donovan, Julie, Liam, and Logan. If you guys are good with what's on this page, just kindly give me a quick G. If you need me to re-explain anything, give me a R and tell me which part, if it's part A or part B, right? Or if it's both of them, let me know. Yeah, that's TikTok there. This is the camera. So you could see yourself. That's now. And you have a hat on. Yeah. It's supposed to be a kind of pink wig, but it's nah, the Afro one is on top. And that one is the camera here. And this, right, this feeding the YouTube and the Google Meet, but it's also that whole thing is related, Chris. So I can just do this, and you'll see all here. Yeah, I did. Huh? This is the Google Meet one, as in like if you join a Google Meet, right? So the image here is fed from the Streamlabs. Right? Yeah. So the Google Meet has one, but it just keeps disconnected and I have no idea why. It says it's in use by another thing, but I think that's good. Yeah, I do. This one? Oh, that's the actual onboard camera there. Yeah, so I just had, I even have more. I have a next one somewhere. What's that? This is for TikTok. This is specifically for TikTok, and this one is for Google Meet. Yeah. But they can hear you. Oh. All right. Hey, Ariel, thank you. Okay. Right. Cool. Next page. AA part 2. So, yeah, go ahead. No problem. That's fine. All right. Just don't take all at the same time. Just take like one at a time now, or like one or two.
No, like,
Oh. Oh, that's fine. Yeah. All right. Derive an expression in its simplest form for fg of x. Okay. So check this, right? What was the function for f? F was 2x minus 1 over 3. Right? And then g was 5 minus x squared. Okay. Right. So if they want you to do fg of x, what they want you to actually do is plug one function into the other. Right? Another way you could write this is like f of g. Or if you prefer, just fg. So it means you want to plug this entire thing inside of here. So what it would look like is this. It would look like 2 by 5 minus x squared, then minus 1, all over 3. From here now, you'd simply use distributive law, because what's the understood operation between the 2 and the bracket? Multiply. And we use distributive law to multiply the 2 by everything in the bracket. 2 by 5 is 10. 2 by minus x squared is minus 2x squared. The minus 1 is just kind of along for the ride. You could rearrange to put the minus 1 next to the 10. Now, don't change any signs. I didn't change any signs. And then 10 minus 1 is just going to give us 9, right? So you have 9 minus 2x squared all over 3. Right? Okay, so again, I'll leave that there for a couple of seconds if anybody's copying it down. Right, now guys, if it is you didn't understand and you copy it down, when you go home, you're going to try the question again. Right? I know you have other stuff in school to do, fine, that's not a problem. But if you don't review what you did, you're not going to remember it. Right? I was telling my class yesterday, I had a teacher when I was in Form 4, Form 5 and Form 6. And he said, fellas, all you do when you go home is read over today's notes. That's it. And I adopted that. And at the end of Form 4 and Form 5, I was able to recite my econ/PUB notes from first day of Form 4 to the last day of Form 5. Like word for word, whole thing. And same thing in Form 6 too. I was able to do 5 terms of econ, MOB, accounts. I could have rattled it off. I couldn't tell you exactly like what was on what date and that kind of thing. I wasn't that good, but I could have just go in order. The same answers, I mean. No. These are the functions. Right? I mean, if you want, the only thing I could think to do here is, right, so you could decompose the fraction if you want. And 3 will go into 9 3 times, right? So you could get 3 minus 2/3 of x squared. But you don't have to. At this point is perfectly fine. But if you want to decompose and go ahead, then yeah, by all means, do your thing. Show them what you know.
So they are actually simplest form.
Yeah.
Still take the one before.
Yeah, they said simplest form. So this might be that. That's true. All right, Google Meet, just give me a quick G if you give me this stuff in the green, please and thanks. If you need me to re-explain it, now is a good time to ask. Right, you should be able to finish off piece of this question again. All right, thank you. Right, I'm missing one person, but when you're ready, you'll let me know. All right, but I'll go on to the next question now because I want to see if I can finish question 8. Sketch the graph of the function g of x in the space provided. On your sketch, indicate the minimum maximum point. All right, let me if I skip it out, that's a problem. Okay. The function g was 5 minus x squared, right? All right. Okay. Now they said sketch, right? This wouldn't have any roots. On your hold on. What was g? 5 minus x squared. Oh, no, yeah, no, it would have roots. Wow, I was completely in the wrong there. Okay. Okay, the function x squared is a minimum curve that passes through the origin. Minus x squared flips this vertically. It's like a reflection in the x-axis, right? And now 5 minus x squared is the same as minus x squared plus 5. So what would happen is that this would shift up. 1, 2, 3, 4, 5. Well, to wherever you put 5 on this axis. So what I think would happen is, well, first of all, let's put some numbers now. So 1, 2, 3. Well, actually, let's not put 1, 2, 3. Let's put 1 here, 2 here. I can't even put 3 there. So minus 1, minus 2, minus 3. 1, 2, 3, 4, 5. Okay, if x is 1, what's x squared? 1, right? So you have minus 1 plus 5, which is 4. So 1 and 4, that's here. 1 and 4. If x is 0, oh, right, so you have 5. And you have 4 here and 4 here. And if x is 2 squared is 4. 5 minus 4 is just 1, so that's 2 and 1. If x is 0, 5 minus 0 is just 5, right? Why does it not fit? Yeah. 1, 2, 3. Oh, if it's 4. If x is 4. Oh, no, it would hit 5 on the axis. No, not 5. It would hit root 5. Yeah, so root 5 is 2.2 somewhere there, right? 2.2 and 2.2. Right, I know I didn't do a good job explaining this one, but yeah. You could do a table, yeah. You could do a table of values, yeah. I should have done that. Yeah. Well, I would just do like 1 to 3, but you wouldn't even be able to fit the value for 3 because that's 9. Yeah, and then the roots here are actually root 5 and in negative of root 5. So minus, so 2.236 and minus 2.236. Yeah. Yeah, okay. I know I didn't do a good job explaining this because I kind of want to do part B and call it a night, but I watch any time too. I might have to stop a bit early, but I want to get number 8 done. All right, so I'll have to come back and redo this one. All right, sorry, I want to skip ahead. All right. So if x is 0, 5 minus x squared. 0 squared is 0, right? 5 minus 0 is 5. That's the y value. If x is 1, 1 squared is 1. 5 minus 1 is 4. If x is 2, 2 squared is 4. 5 minus 4 is 1. Right? And we should use negative values too. Which one? This one? Yeah. 2 squared. 2 squared is 4. And 5 minus 4 is 1. Oh. If x is 2, y is 1.
Oh, see, all right.
Right. So minus 1. Yeah. Minus 2 minus 1. This will give us the same 1 and the same 4. So that's our 1 in x right there. So that. Yeah. And then to find, and then the roots are where it cuts the x-axis. And on the x-axis, y is 0. So you'd have to let you'd have to let 5 minus x squared equal to 0 and then solve for x. So when you carry across minus x squared, it becomes plus x squared. And to undo a square, you have to find the square root on both sides. So you have root 5, which if you plug it into a calculator, gives you about 2.2. Yeah. All right. Okay. I could give you a minute or so again to copy that down. I want to see if I could just kind of hustle through 8 part B. So when we come Monday, we're going to try and tackle question 9 and question. So question 9 is a circle geometry question, trigonometry, which could probably have bearings, sine rule, cosine rule. And then question 10 is your matrices and vectors. Right? So depending on how we move, I might be able to do the vectors question I omitted from the Jan 2025 paper last week. So let's hope we can get that done. Oh, yeah, it's only like 3 a.m. All right. Okay, graph below shows a quadratic function. On the grid above, draw the tangent to the curve at x equal to... Okay, a tangent is a straight line that touches a curve at one and only one point. And they wanted at x equal to 1. So that's this point here. Right? So they want us to draw a line that touches the curve at that point right there. Right? Now, to do that accurately is a bit difficult. So if you're catching your tail to do that, don't dig a horrors. I myself, even with my little technology here, that's a bit of a struggle. Right, so you draw the tangent. So the tangent again touches the curve at one point, which is the point x equal to 1, which I put in. Is the blue? No, the blue's not showing up that well. So let's change that to maybe an orange. That's a little better, right? Yeah, okay. Now, the question then says, use the tangent drawn to estimate the gradient of the curve at x equal to 1. Right. This is not something they normally teach in maths, to be honest. This is normally something you'll see in ad maths, specifically calculus, differentiation, right? So you all know how to find the gradient of a straight line, right? That's m. What's m again? y2 minus y1 all over x2 minus x1. Now for a straight line function, the gradient is constant all throughout the function. It does not change. No matter what point you go on that line, the gradient is always going to be the same. But a curve, right? We also call a curve a non-linear function. And for a non-linear function, the gradient is constantly changing. So it's not constant like on a linear function. So linear function, constant gradient, same value all the time. A non-linear function, a curve, we have a constantly changing gradient. The value is different at every point. And they figured out, hey, if I was able, since we don't know exactly how to find the gradient of a curve, but we do know how to find the gradient of a line, what we will do is we will draw a straight line and make it touch that point on the curve where we want to find the gradient. And if it does touch that point, I mean, it has to just coincide. And it must mean that the gradient of the curve and the line are equal at that point. So that's how they found the gradient of a curve at a point. They drew a tangent to that curve at the point, found the gradient of the tangent, and that was equal to the gradient of the curve. All right? Yeah, it was a bit of a process. Anyhow, so to find the gradient so we can use the same formula here, right? y2 minus y1 equal to x2 minus x1. But we need to find values for x and y. So we need 2 points. The first point could be that same point, 1, 3. Right? So let's call that point A. right? So point A has coordinates 1, 3, right? And you can let that be your x1 and your y1, right? But the next point, right? Now, maybe I kind of drew enough. Yeah, that's good. Okay. Yeah. So yeah, what you'd have to do. Okay, Josh. Thanks for letting me know. I appreciate it. Yeah. Yeah, you can pick any other point. So let's pick this point. This point seems the closest to passing through an exact point. So that point, let's call that point B, and it's on the y-axis. So we know on the y-axis, the x coordinate is always going to be 0. Right? And that's -2. So we could let that be our x2 and y2 values. So to find the value of the gradient of the straight line, so y2 minus y1 divided by x2 minus x1. So -2 minus 3 is -5, and 0 minus 1 is -1. -5 divided by -1, and minus divided by minus is a plus. Why does that seem wrong? Oh, no, it's not wrong. Because look at how many spaces is a 1 on the x. 4 spaces, and how many is a space on the is 1 on the y? 1 space, right? Yeah, right. So to find the gradient of a curve at a point, you have to draw a tangent, a straight line that touches the curve at that point, and only at that point. Then you can find the gradient of that tangent, because it's a straight line, and this is the formula for the gradient of a linear function, a straight line. And then that would be equal to the gradient of the curve at that point. Correct. Right. All right. We have a 8B part 3, but I don't think we have enough time to do it. But I'll take up what it is. Distance speed time. Oh no, it's 1 mark. Oh, now we can do that. So the last piece of one is write down the equation of the tangent in the form that y equal to mx plus c. Right. M is the what? M is the gradient. And what's the value of the gradient? We just found it. 5. What is c? C is the y-intercept. What is the y-intercept? This point on the y-axis through which the line passes, which is what? Well, I have -2.
Oh, 2, yeah.
-2. Yeah, so I have equal to -2. So all we have to do is say that y is equal to 5x minus 2. Right, okay. So folks, we got to put a pin in it there for today. Right? When we come back on Monday, we're going to see if we can round off this paper. All right, I'll see you Wednesday. All right, cool. But we'll see what happened to them girls. I don't know. We'll see what happened to them girls next week, I suppose. All right, later. Right, okay. Google Meet, that's about it for today. If anybody has any questions, they get to ask, you know the drill. Julie, we see you tomorrow for ad match, right? Oh, Julie going, okay. All right, so Aisha, Christian, Liam, Logan, have a good evening and a good weekend. And of course, if you all have any questions, WhatsApp me. My WhatsApp not working that well. The notifications not popping up. But when I go into WhatsApp, I'll see it. All right? I'll see you next week. Bye, guys. All right. Amen. Integral, please. Oh, integration? Oh, you want some AdMath stuff? I have AdMath stuff. Hey, what to do? I'm not sure if I'm pronouncing it correctly. I think it's Amen or Amen, right? What's up? You could DM me on Instagram if you have Instagram or TikTok, or you can email me, right? And I'll see how I can help you, right? Because I have videos with that, but they're not public.